This video clip is part of the EPFL introductory course on information computing and communication. It is the fifth one in a set of video clips on computer communication and networking. It introduces the Internet topology and explains how computers interface to the Internet. Although many different networks have been built in the second half of the 20th century, except for a few special cases, most of these have disappeared and been replaced today by the one and only Internet. Internet was switched on in 1969 by the United States Advanced Research Project Agency under the name of ARPANET. At the time, it connected initially only 4 computers. Since then, the ARPANET technology has escaped from its original US defense mission and context and spread to the whole world under the Internet name. The Internet is organized into a hierarchy of networks and subnetworks. At the lowest level, it includes home and small office networks built around the Ethernet cable and the Wi-Fi wireless technologies. It also includes local company networks, such as are found, for instance, at EPFL or at the CHUV hospital in Lausanne. Then it includes national enterprise networks that are of necessity split across multiple locations, such as, for instance, the networks of supermarket and retail chains like Migros or Coop in Switzerland. All such above, small, large, or distributed enterprise networks are connected to one another through trunk lines and routers owned and operated by national Internet service providers such as Swisscom or Sunrise in Switzerland. The Internet then also includes the distributed campus networks of multinational enterprises such as Nestlé, Google, Amazon, Microsoft, Apple, IBM, etc. In all of these, connect to national service providers in any country in which they operate. In addition, they also connect to one another through trunk lines and routers owned and operated by global Internet service providers who maintain backbone networks to interconnect national service providers into multinational enterprise and public networks. The Internet architecture follows, and in fact defined, the 5-protocol layer model introduced earlier. At the physical layer, it offers a wide variety of interfaces supporting such connection technologies as Wi-Fi, Ethernet, cable TV, ADSL, trunk lines, etc. At the link level, it supports protocols such as, for instance, CSMA-CD over local and metropolitan networks, or PPP over local ADSL lines. At the network level, all routers and end computers, of course, need to support the same Internet protocol, IP, for routing packets across the world. Note that in practice, that protocol includes several internal sublayers and mechanisms that independently manage routing at the local, service provider, and backbone levels. The historical version of IP is referred to as IP version 4, IPv4. It is progressively being replaced by a newer and more powerful version referred to as IPv6. At the transport level, Internet offers primarily a postcard, meaning a single message protocol called UDP. The much more powerful protocol and typical protocol is called Transmission Control Protocol, TCP, or its secure version, which is often referred to as SSL or TLS. Internet also offers a number of other streaming and related transport protocols that make it easier to maintain constant bandwidth connections across the network. Finally, at the application layer, the Internet offers such popular protocols as, for instance, the SSH Secure Terminal Session Protocol, a number of file transfer protocols such as FTP, the dominant Simple Mail Transfer Protocol, SMTP, for email applications, the well-known and popular Hypertext Transfer Protocol, HTTP, for surfing the web, or the unavoidable and ever-present domain name system, which is the fundamental phone book for the Internet. It resolves such names as www.epfl.ch into the actual IP addresses, i.e. the Internet phone numbers of the servers on which the EPFL servers can be found. And many more protocols can also be found on the Internet, but we cannot hope to even start listing them all here. The last topic of this clip is to explain how a computer connects to the Internet to send or receive messages. Implementing this connection necessarily requires some hardware support. In the old days, this hardware support consisted of a whole network card full of circuitry. Today, all of that circuitry can be crammed into a single chip. This card, or today this chip, is full of software that is actually implementing the layer 1 and 2 protocols. That is the physical layer and link layer protocols. On the sending side, this hardware and the software inside it transform the bits in the attached computer memory into signals on the wire or through the air. On the receiving side, this hardware-software contraption inverts the operation, converting wire or air signals back into bits into the receiving computer's memory.